Question number 4. Do refer the question from your textbook properly. So here we need to find the square root by using the long divisions method. Before we start, let's have a look the number and the square. So we know that here 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. Try to memorize the square 1 up to 81 properly before you start the long divisions method. And after that, here the question says we need to find the number of digits in the square root of 6241. So the first step, you'll have to pair the given number starting from the unit place to the moving to the left side. So here this will be one pair, this will be another pair. So each pair we call a periods. So now here how many pair we can give here? So this will be one pair, this will be two pair. So two periods, that means number of digit in the square root will be 2. So after that, here the second one, you'll have to find the square root by taking a long divisions method. So now here take the division format here. After that, what we do here, the first pair starting from right side 62. Now let's have a look the square. You'll have to check, you'll have to take the largest square nearest to 62 or equal to 62. So let's have a look here. The largest square, the closer to 62, that is 49. So now we are taking here 49 and it is a perfect square of 7. So you'll have to take 7 at the divisor place and the quotient place. So 7 square 49. After that, we need to subtract. So we can borrow here, it becomes 12. 12 minus 9, which is equals to 3. So here it will be 5. After that, here what you'll have to do, at the divisor place, you'll have to make it double. One more 7 you'll have to take here. So 7 plus 7, which is equals to 14. Remember that here you'll have to leave a blank. After that, you'll have to drop the remaining periods, which is we have here 41. So after this period, we don't have any number to bring down. That means after this step, we get the exactly 5341. So now for rough work, you'll have to take now this divisor. So divisor we have here, that is 14. Take for a rough work 14. Now after that, here just check at the unit place. Unit place we have here 1. So now when we get a 1 at unit place, remember that it might be divisible by 1 or you may get by 9. So have a try by these two numbers. So if I take here 1, again here also 1. So we get here, that is 141, which is not equal to this value. Again, one more option we have here 14. Take the divisor. Now the second option we have here, the number 9. So again here also you'll have to repeat the same number. After 9 nines are 81, 8 in hand. 9 fours are 36 plus 8 44. So 4 in hand. 9 1 9 plus this equals to, which is we have here 13. So now here it is only 1 in hand will be there. So exactly 1341. So I took the which number 9. So this 9 you'll have to give at the quotient plus 1, then divisor plus 1. So that is how here 1 3 4 1. So now we can subtract these two, same value, so it will be 0. So therefore the square root of 6241, which is equals to 79. So now sub question number 2. Again here the same rule or the same method we need to apply. Now first I need to note the number of digits in the square root of 3249. So how to find out the number of digits? Just you'll have to make a periods. So this will be one pair, this will be another pair. So how many pair? Yes, that is 2 pair. So the first answer we have got. Now to get the second answer, we need to take a long divisions method. So take the number here, that is the first period 32, the second period 49. So what you will have to do, you'll have to take the help of the square. So the largest square closer to 32, if not equal to 32. Let's have a look which one is the closer. Yes, that is 25. So 25, it is a perfect square of 5. So quotient plus 1, divisor plus 1. So that is how here. Now subtract. 12 minus this equals to 7. So 2 minus 2 will be 0. And here what you'll have to do, yes, you'll have to make it double. So 5 means you'll have to take one more 5. So 5 plus 5 equals to 10. Like I said before, you'll have to leave here a space. Now you can drop the remaining periods. So 49. Now what we do? So we don't have any number to bring down. Now you should have to get exactly 749. So take this 10 to the right side. Now just have a look at the unit place 9. So you can just have a look. 9 means it is divisible by, it is a perfect square of 3. If not, you'll have to take the help of 7. Out of these two, 1 will be our answer. So I'll check by first 3. So once you take 3, then again here also you'll have to take double. So now 3 3s are 9, 0, 3. So I failed to get this value. Again, one more chance is there. That is, now take this 10. Now check by the 7. Again here into 7. So 7 7s are 49. 7 1 is 7. So now you can compare. Yes, they are equal. So this 7 you'll have to put 1 at the quotient and divisor also. So now that is how here 4 9. So subtract, the remainder is 0. So therefore the square root of 3 2 4 9 is a perfect square of which number? 57. Sub question number 4. So you'll have to find the number of digits in the square root of 8464. So you can pair them 1 2. So number of digits will be only 2. So now to find out the square root, you'll have to take here a long divisions method. So we have here 8 4 6 4. So this will be pair, this also pair. So you'll have to take the largest square nearest to 84 or equals to 84. So that is 81. So 81 is a perfect square of 9. That means quotient plus 1, divisor plus 1. Now subtract. So it will be 3. Bring down the remaining periods 64. Here you'll have to add one more 9. So 8 plus 8, 9 plus 9 equals to 18. Remember that here you'll have to leave a blank here. So after that here, now check the unit place. 4 is a perfect square of which two numbers? So 4 is a perfect square of 2. If not, if we fail to get by 2, then the check by 8. Out of these two, 1 will be your answer. So have a look now. Take this divisor for the rough work. So here 18. So let's have a try by 2. So even here into 2. So 2 2s are 4. 2 8 will be 16. 1 in hand. 2 1 will be 2. Plus 1 will be 3. So that is, I've got exactly 3 6 4. Now these two you'll have to distribute. One at the quotient, the another one at the divisor place. Now you can subtract. So 0. Therefore the square root of 8464 equals to 92. Now sub question number 5. Again the same step we are repeating here. Number of digits in the square root of 9801 is, how many pair we can make here? Only 2 pair. So 2 digits. Now to find out the square root here, you'll have to take a long divisions method. 9 8 1 pair, 0 1 another pair. Now you'll have to take the largest square closer to 98. So that means here we can take 81. So 81 is a perfect square of 9 9. So now you'll have to subtract. So 8 minus this equals to 7. That means here 9 minus this equals to 1. You'll have to bring down the remaining periods. So 0 1. Now here what you'll have to, yes, you'll have to add one more 9. 8 plus 8 equals to 18. Now check the unit place. What we have here? 1. So you can see here 1 is a perfect square of 1. If you fail to get by 1, then try by 9. So now take this divisor, that is 18. So let's have a try by 1. So here also 1. So that is 181. I didn't get. Now the next number is option is 9. So take this 18, try by 9. Again here into 9. So 9 will be 81, 89. 9 into 8, 72, plus this 80. So 89, 9 into 1, 9, plus 8, 17. So equals to 17, not 1. So here 1701. That is 9. So where to take this 9? The question 1 and the divisor plus 1. So subtract, which is equals to 0. So therefore the square root of 9801 equals to perfect square of 99. Again, sub question number, that is 6. So first you'll have to find again here number of digits in the square root of this number. So make them pair 1, 2. So which is 2 pair. Now take a division method here. 75, 69. So the largest square closer to 75. Yes, that is 64, and it is a perfect square of 8. So quotient plus 1, divisor plus 1. After that you'll have to subtract. So this would be 1, 7 minus this would be 1. The next step, yes, we need to bring down one more periods. So 69. After that, yes, you'll have to add here the same number. So 8 plus 8 equals to 16. Now we don't have any number to bring down, which means I need to check the unit place. So unit place, what we have here, 9. So 9 means it is a perfect square of 3. If we fail to get by 3, there is one more number, that is, yes, that is 7, because 7 sevens are 49. Unit place, they used to carry 9. So take this 16. Now check by 3. 3, 3. 3 3s are 9. 6 3s are 18. 3 1 3 plus 1 4. I didn't get. So again take this the same factor. Now the second option we have 7. Again into 7. 7 sevens are 49. 4 in hand, 7 6 42. Plus this will be 46. 4 in hand, 7 1 7 plus this 11. So yes, they are same. So 1 1 6 9. So this 7 you'll have to distribute 1 at quotient, the other 7 at divisor. Now you'll have to subtract. So that is 0. Therefore the square root of 7569 equals to 87. Now question number 12. Again here, the first step, number of digits you'll have to find out. So make them pair, 1 pair, 2 pair, and this also will be a pair because always they used to carry here 0. So how many pair? 3. So the number of digits in the square root of this number is 3. After that you'll have to take a long division method. So we have here 6 4 5 1 6. First pair, second pair, and third pair. So now here you'll be getting here 3 digits. Now like I said before, here you'll have to take the largest square nearest to this pair. So 6. 6 means you'll have to take 4. So 4 is a perfect square of, yes, that is 2. So 2 4. So now subtract. So here 6 minus 4, which is 2. You'll have to bring down 45. Here, yes, we need to take double. So 2 plus 2 equals to 4. Keeping here a space. Now we don't need to check here unit place. Why? Because still I'll have to bring one more periods. So here you'll have to take closer to 245 or equals to 245. Now let's have a rough work. Take this divisor 4. You can check by any number. So if I take here by 6 times, possible to take 6 6 are 36. So 3 6 4 24 27. That means I can't take because it is 276 is greater than 245. So I'll have to reduce. So take this 4, after that reduce this value. 6 means if you reduce, then 5. Again here into 5. 5 5s are 25. Again here 5 4s are 20 plus 2, 22. Can we take? Yes, because it is smaller than the dividend. So we have here 2, 2, 5. After that here, this 5 you'll have to distribute 1 at the quotient, 1 more at the divisor place. After that, we need to subtract. 5 minus 5, 0. 4 minus 2, 2. 2 minus 2, 0. Now, you'll have to drop this value, 1, 6. What you'll have to do here, you'll have to add 5. So, which is equals to 50. Now, we don't have any number to bring down. At that time, you can check the unit place. So, 6. Let's have a look now. 6 is a perfect square of which two options are there. Look, whenever we get 6 at unit place, your answer may be 4, if not 6. So you'll have to try with these two numbers. One will be your answer. So what we do here now, take this 50 for rough work. So like I said here, 6 possible numbers are 4 and 6. So let's have a try with 4. So 4 4s are 16, 4 5s are 20. Is it same? Yes. That means we have got 2, 0, 1, 6. That is with the help of 4. So this 4, 1 at the quotient place, the other 4 at the divisor place. After that, you can subtract. So 0. So therefore, the square root of, that is we have here, 6, 4, 5, 1, 6 equals to 254. Now the next one. So first you'll have to know the number of digits in the square root of the given numbers. So make them pair here, 1 pair, 2 pair, 3 pair. So number of digits 3. So now to find the square root of the given number, take a long divisions method, which is the first pair 35, the second pair 28, the third pair 36. So here the largest square nearest to 35, that is, yes, 25. 25, and 25 is a perfect square of 5. So 5 means 1 at the quotient, other 5 at the divisor place. Now you'll have to subtract. So 5 minus 5 will be 0. 3 minus this will be 1. So now you can bring down 1 periods. And here what you'll have to do, you'll have to make it double. So plus 5 you'll have to add. So 5 plus 5 will be 10. Now take this 10 for rough work. Right now you will not get 1028 because I need to bring down 1 more periods. So at that time we don't need to check that that is a unit place. Now you'll have to take here a rough, you'll have to take less than this value or equals to this. So we'll have a try with 9. So now 9 9s are 81. 9 into 1 is 9. So we can take this value. So here 9, even here 9. So after that here 981. Now we need to subtract. So 8 minus this will be 7. Borrow. So 12 minus this equals to 4. After that you can bring down the remaining periods, that is 36. So here you will have to add which number? Only 9. So 9 plus 9 will be 18, 1, 1. Now we don't have a number to bring down. That means I need to check the unit place. Now take this number 118. So 6 is a perfect square. Possible number are 4 because 4 square 16, unit place 6. The other one is 6. 6 square 36, unit place 6. That means the possible number are these two. So check by 4 into here also 4. 4 4 16, 1 in hand. 4 8 32 plus this will be 33. 4 1 4 plus 3 7. 4 1 is 4. That means they are equals. So 4 7 3 6. Now minus 0. So this 4, 1 at the quotient, the other 4 at the divisor. So therefore the square root of 3, 5, 2, 8 3 6 equals to 594. Digits in the square root of 10404 is, so you'll have to pair of the number, one pair, two pair, and this will be the third one. So here 3 digits. After that, here find the square root of this number by using a long divisions method. Now we take the number here, the first pair, second pair will be 0 4, third pair 0, again here 4. So this also will be pair. So here 3 steps, within 3 steps we get the remainder 0. So like I said before, here one must have to take the largest square or equals to 1. So here it is a perfect square of 1. So here 1 square 1. Now you'll have to subtract 1 minus 1, 0. So you can drop down, that is 4. So here what we used to do, 1 plus 1, which is equals to 2, or you can add here plus 1 also. So that is how here we have got the sum 2. Remember that here you'll have to leave a blank. Now if I take here right now the remainder not equal to 0, that is you will not get the remainder as 0 because you'll have to bring one more periods down here. So take this 2, the least number, that is 1. If I take here a trial by 1, I get here 21. That means which is more than the dividend, not possible to divide. In that case you'll have to bring down this also, that is the remaining periods. Once you drop this one, remember that here you'll have to take 0 at the same time at the divisor also. Now I've got a new divisor, that is 20. So now take 20 for the rough work. Now we don't have any digits to bring down, which means here check the unit place here 4. Now if the unit place is 4, then the possible answer are 4 means 2, if not 8. Out of these 2, 1 will be your answer. So take this 20 for rough work. So 20 have a try with 8. So into the same number, which is equals to 8 are 64. 8 2s are 16. That means which is not equal to this value. Now the second value, again take this 20. Now check by which number? Yes, that is we left with 2. Again into 2. So 2 2s are 4. 2 into 0 will be 0. 2 into 2, again here 4. Are these two equal? Yes. So I took which number? 2. So that 2, one at the quotient, the other at the divisor place. And here dividend we have 404. Now we can subtract, which is equals to here 0. So therefore the square root of 10404 equals to here, that is we have 102. Now the next number, again the first one, get a number of digits in the square root of this value. So now you will have to pair them, one pair, two pair. Now this will be also counted as a pair. So which is equals to 3 pair. Now take a long divisions method to get the value here. We have now 3 one pair, 45 will be another pair, and 96 also here a pair. Now the largest square nearest to this one, which is, you can see here the largest square will be 4, we can take, that means 1. So and this one is a perfect square of 1. So 1 square 1. Now you'll have to subtract. So 3 minus 1, 2. So we drop this periods 45. What you'll have to do, 1 plus 1, which is 2. That means here what we are doing, just adding 1 here, the same factor. Now after that take for 2 for rough work. So here 2 4 5. Right now you will not get 2 4 5, just you'll have to find out the number less than 245. So we see by 6 6. So 6, this will be 36. 3 and 6 to 12 plus this equals to 15. That means less than 245. But again you'll have to see whether we can take 7 8 9. Okay, so now 2, if I take by the largest number here, 9. So 9, 9, 81, 18 and 9 to 18, 18 plus this will be 26. That means greater than 245. So not possible to take. Now here we can reduce 28. Again here into 8. So 8 will be 64. So 6 in hand, 8 to 16 plus this will be 22. It's possible to take. So now we take here 224. So the number is 8. One at the quotient place, the other 8 at the divisor place. Now subtract these two values. 5 minus this equals to 1. 4 minus this equals to 2. Now drop down one more period here, 96. So here what you'll have to do, that is you'll have to add 8. So that is plus 8. So 28 plus 8, which is equals to here 36, or it can be also done in this way, 28 plus 8 equals to 36. Now after that here we don't have any number to bring down. That means now we must have to get the remainder exactly 0. So let's have a try. Take this 36 for rough work. So I'm taking here 36. Unit plus what we have? 6. Now if you get a unit plus 6 as a number, then the possible number are 4 and 6. So let's have a try with these two numbers. So take here 4. So into 4. So 4 4s are 16, 1. 4 6 24 plus 1 25. 2 4 3 12. So 13 14. So I didn't get. Again one more number I need to check here. So take this 36, repeat the same step, 36. So the next possible value we have 6. So again multiplied by 6 here. 6 6 are 36. 3 in hand. So 6 6 36 plus 3 39. 3 in hand. 6 3 18 plus 3 equals to 21. Is it same? Yes. So 2 1 9 6. So this 6 you'll have to distribute 1 at the quotient, 1 at the divisor. Now subtract, the value is 0 here, remainder. So therefore the square root of 3 4 5 9 6 is a perfect square of 186. Now the next one, now here again, to get the number of digits in the square root of this number, so you can pair them 1 2 and this will be 3. So number of digits we have 3. Now find the square root of this number by applying a long division method. After that here take the number 4 97 29. So 1 pair, 2 pair, and this will be our third one. So let's have a look to the square. 4 is a perfect square of 2. So here that means 2 square 4. Now subtract, it will be 0. After that here what we do, make it plus 2. So that is how here a new divisor is formed. Now bring down one more pair, that is 97. You can drop this value. After that take a rough work. So do I need to check unit place? No. Why? The reason behind is we have one more value to drop down. So now have a try with 2 2, which is 84. Is possible to take? We can't say. Why don't we check by 3? So 3 3 9. This value is greater than 97. So that means not possible to take. So which means we can take here 84. And 84 I took the help of number 2. So here 2, even here 2. Now subtract, that is 7 minus 4, that is 3. 9 minus this will be 1. Now you can drop down the remaining periods, 29. What you'll have to do, you'll have to add 42 plus 2, which is 44, or you can take here plus 2 also. You can follow any method. After that here take this 44 for the rough work. Now we don't have any number to bring down. At that time you can check the unit place. But remember that this step will be applicable if the number are perfect square. So now 44. So I took here 44 for rough calculation. Now 9. If the unit place, if we get 9, then the possible number will be 9 is a perfect square of 3, and the other possible value is 7. So out of these two, 1 will be our answer. So let's have a try with a 3. So 3, even here, into 3. 3 3s are 9. 3 4s are 12. 3 4s are 12 plus the remainder 13. So I've got exactly the same value, 1 3 2 9. After that, this 3 distribute 1 at the quotient, the other 3 at the divisor. Now subtract, the value is 0. So therefore we can say that the square root of 49729 is a perfect square of 223. Now the next value here, now again here, that is sub question number 15, number of digits in the square root of 12,321. The first step, what we do, you'll have to make them pair, 1 pair, 2 pair. So this will be our third pair. So number of digits is 3. Now get the square root of this number, 1. After that we have here 23 and 21. Now see that the largest square we'll have to take here. So the first one, 1, we know that it is a perfect square of 1. So 1 square 1. Subtract, so it will be 0. So you drop this periods, 23. Divisor plus 1, that is 2. After that here, just you have to take a trial. So check by 2 into 2, which is 44. That means we can't take because 44 is greater than the dividend. So now we can reduce 2, 1, again into 1. 21, possible to take? Yes. So here 1, here also 1, and we have 21. Now subtract, so it will be 2. Here plus how many? Yes, 1, 22. Now drop the last period here, 21. So take this for rough work here, which is equals to 22. Check the unit plus 1. If we get a unit plus 1, then the possible number are 1 and 9. So I'll check first by 1. So what is 2 2 1? Is it equal? Yes. So here I took the number 1. So 1 at the quotient, the other one at the divisor. That is how dividend 2 2 1. Now subtract, that value will be 0. Therefore the square root of 12,321 equals to 111.